Okay, so this is the base Solana wallet adapter app. So the idea is that you can toggle on or off auto connect, and you can select your wallet. I'm connecting with Phantom. So we click on select. And we first step is to sign in. And the core actions is because we are on DevNet, we can request an airdrop. So you will click here. Once signed in, you can sign a message. So for example, the message says, localhost wants you to sign in with your account and then your public address. So you confirm, and then you can process the signature, you can save it, and it's a proof that they signed a legal term, for example, a legal action, and this transaction is a proof that this, and by signing this transaction, you can be sure the user has authorized the message. Then you can sign a transaction. So the transaction also will return a signature, but this signature hasn't been sent to DevNet. So you will need to store that signature, and you can then add a signer to pay the fees, and you can send that transaction. Or you can run directly with the wallet of the user. You can sign a transaction and send it. So here you have a successful transaction. You can also send legacy transaction and send version 0 transaction using address lookup table, okay? So this process will also send the transaction, and you can check the transaction on the DevNet Explorer, okay? Okay, so now let's start this tutorial explaining all these main actions with the wallet adapter. Okay, so welcome to this Solana wallet adapter tutorial. The idea is to interact with main wallets and perform actions for your DApp, okay? So one of the actions you can make is to sign a message. The idea is that you will sign a message. This is an example using a Phantom wallet. So the message says your website wants to sign with this Solana account, and please sign in. So every Solana wallet adapter that asks the user to cryptographically sign any text or byte string with their wallet's private key is a no on-chain transaction. This means zero fees. So the signature stays off-chain but can be verified by your front end or back end. Anyone can later verify the signature. You can store this in a database, proving the controlled wallet at the moment of the signing. So let's see some top use cases for signing a message. For example, you can sign in with Solana, replaces passwords. The DApp verifies the signature to authenticate the user, linking identities with social accounts. You can, for example, first sign in using Discord, X, or Gmail, or any email account, and then you can sign in with the wallet, so you can link the identities of an email with a wallet. The next time you can sign in using the wallet. Off-chain DAO or game actions, cheap way to approve lightweight votes, e-commerce, DeFi, order tickets, sign orders or quotes off-chain before the settlement on-chain. User consent and anti-phishing. The app presents a human-readable message. I agree to, and store the signature as a legal proof on the database. So that wallet linked to an email can legally sync a Web3 message without paying any fees. Sign in. Sign in is very similar to sign a message. So the idea is that your website, for example, wants to sign in with the Solana account, and this is your wallet address, the wallet of the user. The sign-in idea is that you can have a passwordless login flow where a DApp prompts the user Solana wallet to sign a one-time nonce. The DApp verifies the signature with the wallet's public key, proves wallet ownership, and establishes a session. Nothing hits the blockchain, so zero fees and instant UX. the core idea is that you generate a session and no fees, zero fees, and instant UX. Top use cases. For example, account-less onboarding signing with Solana. Users access to your app in 2 clicks. No email, no password resets. Premium feature gating. Unlock pay wallet content or features only for wallets holding a token or NFT. Cross-app identity. Let users carry the same wallet-based profile across multiple game or services. So you can have several websites, several apps, a video game, and you can identify the user. Secure voting and DAO dashboards. Ensure every vote or dashboard action ties back to a verifiable unique wallet. Regulatory KYC, know your customer handoff. So you can combine off-chain know your customer provider with a wallet signing to link real identity with the wallet without storing passwords. Now let's see sign transaction. Signing a transaction using a wallet adapter method will ask the user to cryptographically sign a full Solana transaction, all instructions plus recent blockage with their private key. Only the signature returned, the VApp or relayer decides when and how to submit the signed transaction to the network. Enables advanced flows like offline approval, meta transactions, and multi-sig, while preserving normal on-chain security. So for example, user signs a transaction and you store that transaction on the database and you use then other wallet for the fee payer. The relayer submits the fully signed transaction and covers the sole fee, letting the user act on chain for free. So for example, the user can sign that he wants a transfer. He's giving, for example, 0.01 Sol in exchange of an NFT. So he's signing that. And the idea is that you can later process that transaction. Multi-sig approvals for treasuries or DAOs. Several owners can each add their signature to the same transaction. When the required threshold is reached, anyone can broadcast it and the program verifies all signatures in one go. No single person can move funds alone. Hardware wallet offline signing, so the security-minded users assign the transaction on an air-wrapped hardware wallet and then move the signed block to an online machine and they only broadcast it. Their private key never touches the internet. Then for batch and RFQ desk, traders or bots can pre-sign orders off-chain. A desk or DEX post them on-chain, only the price conditions are met, cutting latency and the network spam while keeping cryptographic proof of the trader's intent. The next use case is for bridge and SDK relayers. So when you are doing some cross-chain bridges or advanced SDKs, the user can do a single signature, then relay on schedule the transaction pieces at the best moment on another chain without additional user action. The idea of sending a transaction with wallet adapter, you will need to use this method on TypeScript, then send the transaction, the connection, and the optionals. Is a one-step helper. The wallet pops up and the user approves, signs the transaction, and immediately broadcasts the transaction to the Solana RPC endpoint. It returns the transaction signature ID so your DApp can track the confirmation. No extra code for sign then submit. Everything happens in a single call, so you are sending the transaction directly. Top use cases. For everyday transfers, you can transfer Sol, SPL token, NFTs. Is fast, one-click payments once the user are okay. DEX DeFi action, swap and add liquidity borrow. Needs instant on-chain execution right after approval. For minting, the mint instruction must land on-chain the moment the user confirms. Staking and vote delegation, lock or delegate Sol securely without any extra steps. And real-time game moves, in-game actions update on-chain immediately for seamless gameplay. Now let's explain what are legacy transactions. The older version of transactions, pre-version 0 format that every Solana node, wallet, and RPC still understands. Nothing fancy, just the standard message plus signature. No address lookup tables, alts. every 32-byte account address is written directly into the message. So the 1232-byte cap lets you squeeze in roughly 35 accounts or less. Because many clients default legacy only, choosing it guarantees maximum wallet RPC compatibility requests at current time that don't opt into the B0 will fail on newer formats. Okay, so the typical scenarios is when you do a simple SOL SPL transfer or NFT send. Stack Exchange note that there are no advantages when you don't use address lookup tables. Universal wallet support, including older hardware wallets. All wallets and RPCs accept legacy by default, so you avoid unsupported version errors. Sending a legacy transaction guide still teach legacy first because it's the simplest one-click path. Docs such as Phantom sending legacy transaction guide still teach legacy first because it's the simplest one-click path, and lightweight single program actions stake, mint, and vote. Only a handful accounts are involved, so the 35 account ceiling and lack of address lookup tables aren't a constraint. Version 0 transaction. The first upgrade to Solana transaction header, a version byte equals 0, tells nodes to decode the message with extra features. Unlocks address lookup tables, alts instead of writing every 32-byte account inside the message. You reference the table index, cutting size and lifting the practical cap from 35 accounts to 64 and more in the future. Back compatible. Wallets RPCs that understand B0 still accept legacy. Choose B0 only when you need the extra room or smaller payloads. So some great ideas for using B0 is for aggregator swaps. So each hop touches many token accounts and program IDs. Address lookup tables keep the transaction under the limits. Mass mint or candy machine drops. If NFT mint can call several metaplex programs plus metadata and collection accounts, often more than 35 keys. DAO treasury batches multi-program calls. A single proposal can stake and swap and transfer in one go. So B0 packs all needed in accounts. Packs all needed accounts. Bridge SDKs preview large transactions and relay them when finally is the cheap address lookup table indexing, trims payload and fees. High frequency trading bots. Pre-signed B0 transaction templates with many market accounts. Let bots inject order faster without hitting size limits. So when to use version 0 transactions? Top scenarios. Use version 0 transactions when you need a lot of accounts or smaller bytes than the legacy can offer. Perfect for complex DeFi, for trading, for NFT drops if you have a big community and you want to airdrop a lot of people, and for batch operations.